Cool. So let's get this show on the road. Just checking that my stream's coming up. Should be online momentarily. We are now live. Just waiting for some of the code to come through. Okay, there we go. So today I wanted to chat about the ESP32 game console that I built. It's been a bit of a journey for me, and I thought it would be fun to actually talk about it a bit and see what I could share with you guys. So I think first things first, let's take a look at what we're actually dealing with. So in January, I put out a couple tweets for a game console that I made, and it's quite simple, it's quite straightforward. Let me share my screen, and you can see here that it's the ESP32 T-Go T-Display. This is a fully built-in chip. It's got everything you need to power a battery. It's got the screen built in, it's got 2 buttons built in, and then we've 3D printed a case for it. I will show the hardware a little bit later, but here you can see the game actually playing, and this is the first version of the game that I made. We're live. Cool, so some of the things that I wanted to talk about is the journey that got me here, and some of the code and the way it works, and kind of what I was hoping for that people could do with it given a bit of time. So one of the fun things is it's a straightforward, simple piece of hardware. It's got 2 buttons, it's got a reset, it's got a full color screen, and then on the back you can see over here it's got a JST connector for putting a battery in. Even comes with some cabling around the wires. So for me, this was quite a journey to get to this point where I had the game that I could show. And let's just make sure, there we go. So here is a working version of the console, and you can see it's playing the same game that you saw in the video. Unfortunately, I can't get very good camera quality on here. Okay, and if I press the reset button, it actually switches between the games. This is called Wolf Game. Terrible webcam, but that's all I've got. So the idea is you just run side to side, and that allows you to pick up different things. So in this game, it's stars that you need. It's snowflakes that you need to pick up for the wolf. And once you've picked up enough, you'll power up the bar. And on this game, it is different types of flowers. So when your bee flies over the flower, there's a little power meter bar that you can see at the top, and that powers up. And so when it hits full power, that will be, mission accomplished, you win the game. So it's a really simple gameplay, but it came with like a couple caveats. There's a reason I wanted the gameplay to be simple, and that's so that my kids could play it. So they're 3 and 5 now. They were 2 and 5 at the time where I did it, and they got to play this game. They don't get to play many console games. Kind of find everything's always a little bit too violent, and it's not exactly what we want them to be doing. So we gave them, I put this together, and they can actually sit and play this game for a few minutes until they get bored, and we have a great time like that. I enjoy the fact that they're playing with electronics. I enjoy the fact that they know that these things can be done with computers. So when it came time to design the first game, I thought about it for a long time, but once I'd come up with the idea of it being a bee, I started chatting to my daughter, and she came up with all these ideas of how it could work and what it could do, and I tried to integrate all of those. And I was going away on a trip for a while, and I was speaking to her about it, and she told me that she would love if we could put together another game, the Wolf Game. And so it was quite interesting taking what I had built already, and then just reskinning the game for her, and I added a couple extra things just to make it more fun for her to play, and she really took to it. So like, she has this idea now that we can make things happen, which is maybe a two-edged sword in the fact that there's quite a lot of projects that she's got lined up for me in the future now. One of the other things I wanted to show is kind of like this was a journey for me, and so it's like, how did I get into this, and where does it go, given even more time. And so kind of all goes back to this badge. This badge I got at the B-Sides conference in 2016 in Cape Town. This was made by Mike Davis and Andrew Mohawk, Elastic Ninja and Andrew Mohawk. And then that kind of went into a couple other devices. So I was responsible for the software for this one, and Elastic Ninja put together the actual badge itself. And then the journey for me with my own hardware sort of kicked off from there. I was fascinated with the idea of making my own game console and having only touch buttons. So these are actually touch buttons with the ESP3266 and a little black and white OLED. At that similar point in time, I found out about another console that someone was working on. It was the Boy. Let's see if I can actually get anything worth looking at here. So you can see this is someone else's, excuse me, this is someone else's console, and it's quite cool. So this is the Boy. All the specs are open source. This is just playing Breakout. It's one of the demo games it comes with. And what's really cool is the guy who made it, he's allowed for pretty much anyone to take that hardware and go and edit it to run on whatever they want. So this ended up being very close to the original hardware, whereas this one that I did a while back runs on a smaller display. Like it only uses a couple cables instead of like all 8 of them. And here we go. You can see this one's got sound. And then so all these games, is kind of fun to have a console that someone else has written games for, so you don't have to only play your own code. And then on the back of this, it's kind of started getting fun to actually see what I could make myself. So the things that I've made myself, I've been playing around a bit with this kid's console that I made, and also with the e-paper displays I've kind of got going. So I had an idea to make a game where I took the Boy and I took a relatively slow running game and got an RPG running on a e-paper display. I thought that would be a fun thing to do. I did manage to get that up and running, but that's sort of an aside for now. So yeah, it's kind of just wanting to show that this sort of stuff is a journey. Like if you think there's nothing you can do to get into this, it's kind of like everything's been like a small incremental step for me. It just took the original getting started on a badge that came out at a conference. I think like 2 years after I went to the conference, I finally picked it up and decided that I was going to do something with it. Cool. So yeah, let me think more about this. So you can see the fun things about this, and what I've learned is that I need a quick cycle on everything I do. I really need it to be interactive. I need to feel for the code that I'm editing, and I really want to be able to run my games locally on my machine. And obviously that's not the exact same as running it remotely. Like, you've got more hardware constraints on the actual badge itself. But in the case of the ESP32, it's like quite well known what constraints it has, and you can actually work around it for the most part. So what I actually ended up doing here is, like, once you've got the system up and running, it's quite nice to have something that you can run locally. So you can see here I'm actually playing the game, and you can see that the version of the game that runs on the badges is exactly the same as this. I find that feedback loop very helpful to me. So now if I want to make a change, then any change that I want, and actually in this case you can see I've got a comment here, go between B game and Wolf game. I quickly build, And without having to upload to the badge, I can actually come back in and play the game. Cool. So some of the things I wanted to talk about for the badge are how the code works, what it does, why it's cross-platform, how the cross-platform works, and I'll kind of just start from the top. Yeah, you can see the wallfires coming in. Problem with writing games is sometimes you get like a little bit too much into playing them yourself, but that's actually a really good thing. Your own play testing can kind of like get your game mechanic in. So for me on this one, a lot of what I spent my time with was trying to get the feel for the movement right, and also getting the amount of difficulty correct for like a 2-year-old and a 5-year-old. They needed it to be easy enough to play that they could actually come into the game without much issue, and I didn't want to have failure being something that they had to worry about too much. So the way the power bar works is very catered to giving an eventual win. So even when like a 2-year-old's playing the game, eventually they will win. Eventually they'll get the satisfaction. Yeah, I'm not all about always winning, but in the case of this, it was something that I wanted them to have fun with. So there's a couple things. So even from here, you can see I've got the different platform code. So in most things, I actually generally do start with the hardware that I want it running on. I make sure that I can get the device up and running. I make sure that I can get the specifics. So in this case, the different buttons needed to be set up, the analog to digital pin, so I think that's for detecting the battery level. Touch sensors actually from a different project, getting the screen up and running, making sure that if I want to have a buffer for the screen that I can use that. But yeah, I'll start with pretty much what it looks like to do the actual screen in here. So for getting the screen up and running, we're pretty much using TFT ESPI, which is a great library, but you do have to set it up specifically for whatever you're using. So there'll be 1 or 2 header files inside of the ESPI library that I need to go and modify. And in actually the newer ones, so a lot of the hardware that I've been working with, just in the case of this badge here, this is the same screen, also runs off TFT ESPI, but it's a 240 by 240 display. So thankfully, we can actually use the same setup for both screens, but it's just an include for a header file. This is holdover code for the analog sensors. The battery code is correct, that's still used in here. And then getting the read shift. So in the case of porting over the framework, this is the button values. So you actually get the button presses get pushed into just a special byte array where every specific byte in the 8 bytes has on or off. So you can tell from the position that a byte is in whether that value is in use or not. So you can see I'm pushing this button press, which is a boolean, was the button pressed, into P1 top, which we can see over here as the different bit positions. So bit 0 is left, bit 1. So in a case of an array like this, 8, if bit 1, depends on which left or right ordering we're using. So that's all buttons off, all buttons on, and then something like that alternating. So if we say this is bit 1, then we can see that P1 left is off, where P1 top is on, P1 right is off, P1 bottom is on, and then so on and so forth. So it's quite a nice way of representing what your buttons are in a single bit. And what's cool about that is once that's done on any of the platforms that I work on, as long as I can implement that, this button values, so you'll see it's sitting in an ESP32 file here, it represents the same thing everywhere outside of this file. So if I go into the game SDL, which is the SDL implementation, we can see we got a get read shift, and this code is completely different, But what it does is the same thing. It's trying to push the bits into the right place, and then it returns it afterwards. So if we see where get reshift is used, we'll see that in-game, I process the input to see what the input's been set to, and then I'll use it everywhere else in the games. So this process input, it will take in the up and down keys, and it actually sets a struct that I put through into all the other games. So player keys is actually a struct, and it's rather labeled everything. So I've got my up, down, left, right, A and B, and start and select, and these are the 8 buttons that I've kind of written most of my consoles with for now. In the case of this TT-Go T-Display, I'm only using the 2 buttons, so the games just have to cater to only those 2 buttons. And that's so for that, for instance, is how you do basically your input in a cross-platform way. So it's just wrapped in 2 special files. You'll see where I call in ESP32.h, it'll be just an ifdef. And so this is one of the core files. It's calling in if I'm using SDL, then it uses game SDL. If I'm using ESP32, it uses that. At some point, I've had the ESP8266 SDL. I've had a Linux console, a Windows console, and I also had Mscriptum for WASM, so that you could actually run these games in a browser. One day I'll get around to actually doing all of that again and wrapping it up a bit better. And then to go for the screen code, so I'm using SDL for the screen and the input. So get raw input, there's center screen. So this relies on a couple things. So the game buffer actually has something called a console buffer, and the console buffer is a uint8t, so that's a number between 0 and 255, and that represents a color. So and it's RGB. There's 3 bits for R, 3 bits for G, and then 2 bits for B. So the 3 means 8 colors, and the 2 means only 4 colors. So the blue only gets 4 colors, which is a bit of a rubbish run, but it is what it is, and that's how it works. So in the case of this, we're just sending in RGBs. I just create them straight up. In the case of this renderer for game SDL, we're just converting them to 256 color red, green, blue, which I think equates to 32-bit color with 0 alpha, 24, and then 0 alpha, so it's actually, it's 32-bit overall. And then inside the ESP32, I actually ended up, because the screen isn't actually RGB 332, it's RGB 565. And so what I did is to be able to do the conversion faster, I actually created a lookup table, and this lookup table takes those 256 colors and converts them into the 16-bit space much better, where you can see it goes up to full white, starting with black. And that kind of covers that. For writing to this TFT screen, I went through quite a lot of mechanisms for this. They've got a whole bunch of different things you can do, smart things. You can push the whole display in, you can push the whole image in if you want. Everything I did ended up being quite slow. This library's got like a lot of helper methods, and they are great for running things, but when you're looking to get your maximum frame rates out, I found just actually bashing all my pixels at the screen work best. So I start the write, which is the most basic operation you can do. It says that you're going to be writing to the screen, and just to accept everything you do. Set the address window to the entire screen size, and then after that I go through every color, and if the color is the same for consecutive pixels, then I keep counting them, and then I'll write the color using the lookup table to get to the 16-bit color table, and then for however many of those characters. So on a screen where it's a single color, it will do up to 256 batch writes at a time for that color, and so it ends up being a lot faster. There's a caveat to this counter logic. I should have 255 as the max, but that's an integer counter. No, that's fine. So that can be the full pixel count. And then at other points in time, I've needed the screen to be rotatable. So you can put in like a bunch of funky code even for each platform in here. If we go look at the STL version, which we were earlier, this is a much how do we say, like, cleaner implementation. It's just drawing whatever the colors are to the screen. We haven't really got any performance issues on the desktop. So that's screen input. One of the other things that I found quite difficult was timing. The way the Arduino IDE works, I couldn't actually separate that out. So I think that sits in platform core. And you'll see in platform core I defined a bunch of things. One of those is get time in millis. And so the different platforms didn't actually support getting time in the same way. And one of the core things about doing cross-platform work, you're going to be running at different speeds on your different platforms. So when you want to know how far to move something, you actually need to know how long it was since the last time you moved it. So if a car is driving at 100 kilometers an hour, it needs at 30 FPS it'll move a certain amount every frame, and at something like 12 FPS it'll only move a certain amount every frame. So you need to kind of cater to that, and one of the easiest ways is knowing how long was it since your last frame, and you do manipulations on your game logic for that to only do everything based on time. So platform core, let's see the actual implementation. So get time in millis. You'll see there's a couple implementations of this. Here's the implementation for Windows, I think it is, SDL2. So it's SDL get ticks, and then ESP32 is delay. Sorry, just millis. And so both of these are now returning the same thing from the same method. So anywhere outside of this file, you'll only ever refer to get time in millis. So one of the things is when you write cross-platform code, it's usually easier to try and stop yourself from doing all the things all the time. I did have some of my code, it was littered with these for a long time, probably still is, depending on where I was in the development. It's littered with a lot of extra things. So you can see here, if I press up and down, that will put on the debug. Let's take a look. Here we go. So this is the FPS. You can see the FPS display at the bottom. And one of the big things for the PC is that I actually know that I don't want to run anything over 30 FPS. And so update min time is something I implemented, which is just something to manage the time. And so I know that I never want to run it more than 30 frames a second. So I want to have a minimum sleep time between frames of 33 milliseconds. So if at the point where I've sent everything to the screen, I've only used 10 millis, then what I'll do is I'll sleep for a couple more. If I change this downwards to something like 2, we can take a look at our game now. And we'll see, okay, so in this case, it's actually running too fast at that speed. So there isn't actually enough time for it to process what's gone on. Well, my code isn't as cross-platform as I thought it was. Okay, well, finally we're moving again. So let's try the other way around. If I make it 60 milliseconds, we can maybe actually force the game to run at half the speed. And you can see the game's still playing at the same speed. The bee is still flying at the same speed. but the game looks a little bit more jagged now. So you can see fly speed and the way the bar is going up and down, like everything's looking good. We come back and we put this back to 33. And here we go. So moving again happily. And there's the 30 frames a second again. So I just must have some logic in here that's causing this to have a bit of issues. I did find this very useful. So once you start having code, like you'll end up doing something really cool on the PC, and then you'll put it across to this tiny little device. And you're sitting here, this thing, like it can't do everything. It's only got 540k of RAM, and you're using a massive portion of that for its frame buffer. So what will happen from time to time is you'll start getting memory errors, you'll start having performance errors, and what helps a lot is to actually go onto the device, get it running, get some output going. There is some checks that I have in place. So there's heap integrity check, which I can do. So actually in this case, if it's debugging, then it does the heap integrity check. It is like quite a performance sucker. So what happens is if anything goes wrong with the heap and I have a memory leak, so if I write to the wrong place in memory because you've got unchecked pointers potentially, then what will happen is I'll put a red block on the screen and I'll write heap corruption, and then potentially crash out. Also, if I put the heap on, if I put this debug screen on a certain amount of times, then it will actually go into OTA mode, so over the air updates, and you can actually update this batch over the air then. There is also the Arduino functionality inside of, okay, so it's not set for here. Oh, it is, okay, good. There is also Arduino functionality built into Visual Studio Code. I use this quite extensively. I think I've broken it since then, but we'll see if this actually compiles through. It'll take a minute or so. And so if this compiles here, you can actually do your uploading to the device from here as well, which is quite nice. It's nice to be able to work in just one IDE. I haven't touched onto CMake yet. I think I'll leave that as like just for the key and beans at the end. So this is a problem that I think cropped up due to something to do with my setup, but the way this is written, you can actually open it up in Arduino IDE as well, which is actually one of the things I'll show you. So the way that the Arduino code runs, if you ever run a new project, you'll see that there's two things. There's setup and there's loop. And so in case of Honey Hunter, you'll see that because I'm trying to run something cross-platform, the Arduino IDE unfortunately uses things called ino files, .ino. And so any of the code that sits in here won't be seen by any of the other versions that I can run. So in my case, SDL. So all I do inside of this file is I begin the setup, begin the serial, and that allows me to print stuff to serial if I want to. And then I do my game init, game setup, and on loops, I'll do game loop. And so this game loop is actually sitting inside of a C file, and that lets me change anytime I want. So see game loop. You see there's the code where we're calling the game loop from the ESP Hunter ino. There, and then the other place that we call it from is game SDL. So this is inside game SDL. I've actually got my main, so this is the runner for this platform, and what it does is the first time it runs, it does everything I need to set up and run, and then it just goes into a hard loop running game loop. So essentially they're mimicking the same thing, and this is just how they get onto the same code path. And let's do a verify here. So Arduino IDE is quite an important part of this whole process. If you've never used this before, you can get it from the Arduino website. There's a lot of articles that will tell you how to install the ESP32, but basically it's file, preferences, and then under the additional board manager, you can add your different boards. So this is the ESP32, the ESP8266, and here's the Arduboy package, and there's some other SparkFun boards that I wanted. Cool. As all good demos go, you can see my code's broken at the moment, but that is fine for now. The code in the repo does work, it's just my actual local setup that's not 100% right now. So the CMake, we're back on there. So the CMake is a pretty cool package manager. This allows you to CMake, it's kind of like a maker. So this actually helps you compile and build your projects, and then it can bring in different packages as required. So in my case, it's just STL I need here. And if I'm on Unix, it will be a different way of bringing in STL just from the issues I had, and then anything else you want to do in here. You could potentially add your Inscriptum build into the CMake as well. I found I was doing it from the command line initially. Cool. So that's those two. Been through that. This is Andrew's blog that he did when he released the badge. Very, very cool. He covers it very extensively, everything they did, how they got it up and running, getting the screens going. Yeah, kind of inspired me to write my own. So I initially actually built my own game console using this. It was here we go. It was this one, yeah. So unfortunately, after writing code for this for a very long time and having the most amount of fun with it, I managed to destroy its USB port that used to be over there. I even managed to rip the trace out by mistake. I was just, I think, plugging it in a billion times and just not being very careful with it. It fell off my desk a couple times while I was connected. So actually, that's an interesting segue potentially. This is a printed PCB. So this is pretty close to a professional short run product. This is a printed fully assembled board. This is professional many run, like hundreds of thousands board. And then this is a breadboard. This allows you to put a chip in. So you'll see over here the breadboard will take the chip that I've got. It's got the pins are all in a standard formation. This is called your rail. This is called your rails on the side. So you can put your grounding and your 5 volt or 3.3 volt, and then connect everything up via that. And so this is actually quick for prototyping because you just plug cables in. And then another alternative, when you get a bit further down the line, this is called a proto board, which is similar to the breadboard, but this is more permanent. So when you plug things in, you actually end up soldering wires into place, and it gives you a slightly more professional finished product than what a breadboard does. But after that, your next steps would definitely be going to a better solution like a printed PCB. So it's actually something that I'd love to do in future, which is actually get my own PCBs printed for my project. So this is on my blog, ttech.mamacourse.media. That's one of my latest blog posts. I don't actually post that often, but I had such an amazing journey with this badge originally. I got a couple games up and running, and this was my first thing that I did. You can see there's Inscriptum, so it's actually running in a browser, this black and white game that I wrote where I was going down hallways, Doom type code. And this was a bit of a demo. When I had plans of writing my own game engine, it's fine for a couple games. I managed to do 6 or 7 different games on it. And eventually becomes a feature game. So all of these things that I learned from my hundreds of years of gaming, it's got pixel perfect collision detection using the bitmaps from the actual things I've used. On these small devices, you don't actually get maths, fixed floating point maths units, so FPU. So what actually happens is, to do those, it has to emulate them in software, and the emulation in software is really slow because it's very generic. But if you actually do your own fixed point maths, you can lose a lot of precision, but what you gain in that is the ability to do things that weren't possible before, speed-wise. And so this is a smooth zooming, which allows us to go and see the zoom on this image, and I can do this rotation in real time on hardware that wouldn't really be able to do something at 30 frames a second if it was trying to do it using the exact maths. So what fixed points maths is, it's using a much smaller number to represent something in a floating point. And then that kind of in turn allows you to do more complicated stuffs as well. This is a voxel scroller on a black and white screen. It was an ill-conceived idea, but it was running at 10 frames a second, which I was quite happy with. You can see turning left, accelerating over the landscape, stopping, and I think I turned right as well. Yeah, so there's turning right. If you can see it, congratulations. It wasn't the easiest. It wasn't the most well-received thing that I did. And so going a bit further, this is showing the follow-on badge. So this is actually only 256 colors, but is using the 16 color mappings that I showed earlier. So all my code is on my GitHub. It's on github.com, TonyM128. You can go take a look at whatever you want there. Company I work for. And one of the repos is the ESP32 Honey Hunter. And it actually also includes the STLs. So if we take a look, I'll have to just download this quick. And go back. Lid. So there's 2 versions of the lid. I've got bigger. Oh, very nice. There's the lid. We can take a look at that. So this is the one of the pieces. This is the taller version to accept the battery. And then we can see the base. Oh, sorry. Base tall should have been it. There we go. And so here you can see the 2 different parts. I actually super glued it together because I didn't want the kids to take it apart. But hopefully that makes it something that will last a little bit longer as well for them. So anything else to show from a code perspective? The way this works, so game is kind of the biggest part of this framework. If we go up to the top, you'll see I've spoken about fixed points, of the fonts. So to be able to have cross-platform fonts, actually just implemented my own font, and it's a simple array. You can see here on the slightly, probably not, you can see here on the preview that it's just a zeros and ones for a bit array to show the actual characters, and then you can just pull the characters out of their positions. All the fonts are fixed sizes. It's I want to say 8x8, but I think it's a bit less than that. And so those you pick out the characters one at a time, which you can do with some simple lookup tables that I'll have in my font.c. So based on the character that gets returned, it'll know where to pick that up from in the code. so there's my font, check the map for X, and it returns it in a certain color. So what this does is it builds up a font in the color that you want to show it, and then returns it to the caller. I also found there was a lot of use for having a double size font, so I actually wrote the code for that into the font class to be able to do that. Pig font is just an encrypted font that we used on a project that we did, the B-Sides 2019 badge. Secrets was just a way for me to know where I was putting all the things that I mustn't check in, and eventually I did write the excludes for it into the repo. Here's if I'm running on an ESP32, so it's just that specific code, and then we get into the more generic code. So badge state was a way of knowing everything I needed to about the badge and then being able to pass it through different menus. The game buffer, like I said, is just to kind of keep track of everything from the screen width and height to the maximum pixel, so you don't buffer overrun, as well as the console buffer that's common across all the platforms. And then we get into a lot of the common code. So some of the functions, process key is obviously one that I went through. That's to actually process the bytes into the players. That gets done in the actual game code. So when you start writing your own code, you can start to leverage that right from the get-go. And then there's a lot of collision checking code. Almost everything I do needs collision checking of some sort. So you get the basic rectangular collision checks. This is pretty interesting. So this is pretty much straight code. If your box overlaps another box in any way, then you have had a rectangular collision. But what happens is, if you've had the rectangular collision, then you actually need to check for mask bit collision as well. So here's the two rectangles, and then you'll have to actually check based on, is the bit in object 1 set to 1, and is the bit in object 2 set to 2, to say that this shape and this shape actually have a collision over here. And then that's not a rectangular collision check, which would be that rectangle and that rectangle overlap. So the rectangular collision check is obviously the one that you always do first because it's very easy to do, but then it leads into the second collision check where you actually do a more thorough one. And so this actually extends from 2D into 3D as well. You can do a cube collision check that will then turn into an object collision check where you start using the polygons. Some other common methods, so just clearing the display, drawing an object to the screen, displaying an image. In bhunter, I had a specific need for displaying that image that runs up the screen the whole time. So you'll see this. It's actually a single image. You'll see the river ending at the bottom there, and then it's starting again there. So this actually loops over pretty quickly. The idea was to have a bunch of images and then change it. The kids seemed happy with this game as is and would rather have different games now. So my dreams of putting another 10 backgrounds in didn't seem to pan out. The bit checking stuff is actually kind of interesting. So like I have this screen in full, if we actually go into the files, hopefully I have stored it. So let's open this up in Explorer. You'll see that we've got the BG river. Where's that? There. So this is the actual image, but then I've got the river mask, and you'll see this is actually a mask for the river to show that where the water is and where the mountains are. So it's a, if we flip between the two, you'll see that I've covered the mountains over here, here, and here, as well as the water. And then I use that when I'm randomly placing the flowers. They cannot be in the water or the mountains, and so it has to place it on the land. That's just a simple way of doing that. With this one, because it's a snowflake falling for the wolf game, I actually could avoid that entirely, which was a nice bonus. But then the draw image infinite, it just knows to keep scrolling it off the screen. So I give it arbitrary pixels and then a bitmap that I want it to draw, and it will keep drawing it for me. Draw screen double. On some of the older demos I did, there was an issue with some things running slowly, so a quick way to speed things up, just actually draw it at half the width, half the height. It should take a quarter of the processing, and then you can just draw it double size. And you'll get 4 times the speed improvement, and it'll still be full screen. Draw object double, this is to just draw a singular thing double on the screen. Draw block, just draw a square block. Rotate object, like I showed in that earlier code for that rotating logo. This can rotate any image to an arbitrary angle. Flip object, so a lot of the time people will use assets both ways. This can help you do that. Inside of the land scroller, the voxel landscape, that relies on being able to draw vertical lines very fast, so there's an optimized version of that. These are all the string drawing methods. Making a color, so make color 565 from the RGBs. This is just, different implementations ended up needing different things, so I do have all the different methods of doing that. Calculating current FPS, drawing FPS, those are generic, you use the same code everywhere. Initializing, setting it up, we went through the update time. This check time was an interesting one. It was just to see whether a certain amount of time had passed. So if 5 seconds had gone by, then you could move on to the next step. Get lapsed milliseconds and seconds. This was just helper methods. Showing image was a way to show a full screen image. And show logo was a very specific code. Fade to black and fade to white I did use in some different scenarios. It's quite interesting that this code was relatively complicated, more than I thought, but you do have to kind of fade pixels in a certain way to get something that looks good. You can't just get a uint value of 255 and start minusing 11111 because of the way the components work. It's the R, the G, and the B, and the way that your bits work. You're going to be manipulating the blue the whole time, and then the green, and then the blue the whole time, and then the green, and then the red. So you have to actually get whatever's currently what your current values are, and then you can add onto those, and once you've added onto them, then you can get your new pixel value, and then you can say whether it's changed or not to know whether you've faded to white yet or not. And that actually takes us to the end of a lot of these methods. So game eventually passes off onto my game, and inside of my game you'll see it's where we implement a lot of our code. Normally I'd recommend that you implement some sort of menu because you always need it from the start. So you can see that I tested out the scrolling, I tested out the sprite animations, just all doing the small demos. A lot of this code still remains in here. I've just shortcutted it to go to the B game or the wolf game now. And then breaking up your code, one of the most interesting things I found is sort of like a state engine type framework. So when you're running the game loop, every time it comes through here, should it be doing something? Yes, it should be doing something specific. Which game mode am I in? If it's in game mode 0, it's just scrolling in background. Game mode 1, it's the B game. And so you can see, is this the first time I'm in here? Well, initialize the B game. Every other time, it's like to the input for the B game, update the B game. If you won, then it enters into a different state, does different things, otherwise it ends. For here, state number 2, this is going to run the initialize if it's the first run. It's going to do the input and update, and then it'll do the display. You can see over here, if you haven't won yet, clear the display, scroll the background, draw the snowflakes, animate the wolf, draw the wolf status. And so, yeah, it's a relatively simple idea, and yet it ends up actually helping so much with the separation of your different things. I found it very good to keep input separate from updates, separate from drawing. And so here you can see this is all my input handling code. I'll never have to do anything with input again. I don't have to worry about why my B is in a certain position or not. All I've done is I've taken up, if you pressed up key, then I'm going to move it left. If you press right key, I'm going to move it right. And all of this is handled by with the time in milliseconds that I keep track of. And then any time after that where I want to know where to put the B, I just put the B in the right place. So update B game. So now I know how I've moved my character. Now I can check updating the B game. I need to know the X and Y for the B. So those are just positions. I need to know the flower positions. I can do all of those. I need to know whether I'm on top of a flower or not. And animate B. So this is the sprite handling for that. You've got a start X. So we need to know, depending on how much time in millis has passed, I'll know which frame I'm meant to show out of the F frames. And then this is some of the handling code. So I know the sprite is 32 pixels wide, so it helps it pick it out of the sprite sheet for the B. Which typically I don't think I've saved. Ah, there it is. So here's the different sprites for my B. And it's got some alpha on it, obviously. And so the B going up and down through a cycle. And so this gives that nice effect of the B flying. There we can see our little bee flying, flapping his wings. And you can see that his head doesn't stay stationary, it actually goes up and down. I felt that gave a very nice feeling to it. And as I mentioned earlier, scrolling the background. And then, yeah, so the initialization, it's always nice to have these variables. So what you can do is, like, if you're using a struct, you can set default values in there. You end up having this idea that that's what they're meant to be when the game starts, and they should always be that. But if you want to reset your game, there won't be those values anymore. So I find it's quite nice to explicitly set the things that you want. Yes, drawing flowers and our B status to show us where we are. And draw object scroll loop is one of the things that I used there. And so this is actually the thing that does the scroll loop. So yeah, when you end up using the same framework for a couple of projects, you kind of get quite a lot of overlap in the end, unfortunately. And then, yeah, different things seem to get used in different games. Yeah, I would say the whole game that I've done, it's possibly time to start a new one. And then for Wolf game, yeah, you can see the implementation as well. It's mostly a copy paste of the other game, but just to get it done quicker, I think I had one evening to hack this together. I just went and pushed all the code through. The drawing the snowflakes was really nice. It was rotating an object with alpha. It gave a much better feel to the game. So originally I had it without the rotation. I imagine this will still work. If I go change the game mode, there you go. Cool. Apologies. It's the problem I remember having code reviews when I was younger. Don't leave commented code in. It's always broken when you want to use it. Yeah, so I think that covers what the B game and Wolf game are and a bit of the framework around it. A lot of these things, you just kind of build up your library or repertoire of skills over time, and eventually the things start coming back to you faster every time you do it after that, which is obviously quite helpful. So I found that over the course of this, I've kind of learned to do certain things, and I keep doing them, I keep getting better at them, and every time I come back to this, it usually happens a bit faster. I did say relatively recently when I started trying to work out this e-paper display. I still think it's one of the stupidest things I did. Just putting an e-paper display that permanently has my face on it now with no power. For me, still, every time I pick a new piece of hardware, it's one of the most humbling experiences ever, because I usually battle to get all the different aspects of it up and running. I'm kind of due for a new learning curve some point in the near future, which is I would like to get the ESP32 build files, the CLI type build files working, and that's like make menu config. It's quite an interesting system, and then there's also platform I/O, so that like it gives you more access to the core systems. And then for other things that I'm hacking on, I was quite keen to show some of them, but it'll be if there's any interest, I could always do this again in the future. Wrong place. Where's me? Me. I got a bare ESP32, so just the chip, relatively similar to this chip. This is a 8266, but I've got ESP32s that look exactly the same. To output to the TV, and actually with a PlayStation controller, so he has a PS3 controller hook. He has a PS3 controller hooked up and playing a game on the TV. So it's just a bare ESP32, connects up to the PlayStation controller, and with two RCA clips or alligator clips, I can connect it to the RCA on the TV. Here's the image I showed earlier when I wasn't sharing my screen. Got the output working quite nicely. All this code and stuff was sort of done by BitLooney for the TV out, and the Arduboy conversion was done by another guy, and then the PS3 controller managed to find from another person that, and yeah, so it was an interesting journey so far, but I'm looking forward to actually taking it further. I think I'm quite keen on writing my own game. I'm looking at doing a car driving game at the moment, like a little top-down racer, and we'll see if maybe that pans out in the next month or two. I could do a broadcast about that again. Anyway, thanks for watching. If you have any questions, feel free to shout them at me. Yeah, I hope you had fun watching all of this, some of us, and if you're interested to see anything else I'm working on, give me a shout.